We'll be learning about the composition of functions. A composition usually looks like this. You have f of g of x or f circle g of x. A composition of functions is basically when you take the output values in red, or these two functions, or the y values from the inside function, once again in red, and input them or make them into the x values for the outside function, which in this case would be f of x, right here. Basically, you're plugging one function into another. And first off, we can visualize this by using an actual number. For example, if we have f of x equals x squared plus x, and then you have g of x equals 2x minus 2, what is the value of f of g of 4? And first, we would solve for g of 4, obviously. So you'd say g of 4 equals 2 times 4 minus 2. And this is just literally plugging in the number for the x value. And we can see 8 minus 2 equals 6. So g of 4 equals 6. So now we can replace the g of 4 here with 6. And now we just do f of 6. And this would now be easy to solve because we can just do f of 6 equals 6 squared plus 6, which equals 36 plus 6, which equals 42. Now similarly, we can do this, but without having a value for g of x. So instead of plugging in a number that represents g of x, we can just plug in all of g of x into every occurrence of x in f of x. So if we have f of g of x equals, now you put all of the inside term, which is g of x, which equals 2x minus 2. We put it into all of the x's in f of x, which actually equals x squared plus x. So we would replace this 2x minus 2 with this x and this x. So it would look like 2x minus 2 squared plus 2x minus 2. And don't forget these parentheses here. Those are actually very important because now you can see that you're actually squaring the entire function. If you just did 2x minus 2 squared, you'd be squaring the 2, which is wrong. So now we can solve this by doing 2x minus 2 and then foiling it. So you have 4x minus 2x minus 2 is negative 4x plus negative 4x. You get minus 8x. Oh, this is 4x squared minus 8x. And then negative 2 times negative 2 is plus 4. So now this would be our composite function. We can also do this other way, where you have g of f of x, which would equal, here you plug in f of x instead of every occurrence of x in g of x. So again, g of x is 2x minus 2, so you'd have equals 2 times some value, which would be f of x, minus 2. And f of x, we said, was x squared plus x. And now you just factor it out. You factor the 2 into this. Sorry. So you have 2x squared plus 2x minus 2. And that would be your function, equals 0. And that would be our composite function for g of f of x. Finding the domain and range of a combination is actually slightly different from finding domain and range of a normal function, since you also have to consider if what you are inputting is also valid. So to find the domain of the composite function, you first have to find the domain of the inside function using your domain busters. And then you find the domain of the resulting composite function and combine the two domains of the inside function and the composite function. So if you have f of g of x, you would first find domain of g of x, then number one, then number two, you would find the composite function, and then number three, you would find the domain of the composite function. So this is all for domain, and then to find the range of the composite function, you use the domain you just found to restrict the function and try graphing it out to see what numbers it contains. So you may have to plug in the extreme domain values to find out the range specifically. You should know how the function looks, as you just have to apply transformations to the 12 basic functions you already know. So that would be find domain of composite function, and then number two, you would actually look at the composite function, and then from that you would find the range. So this is an example where we have f of x equals square root of x and g of x equals 1 minus x squared. So using these, we are supposed to find g of f of x. So we can write out the equation 1 minus, then leave this blank where the x is supposed to be, and square. And now we plug in f of x into where the x was supposed to be, so you have square root of x. Now this is pretty simple because the square and the square root cancel out, so it's just 1 minus x. And this is our composite function, so this is g of f of x. Now we find the domain. So the domain of this function would be, of the composite function, would actually be all real numbers. But remember, we have to look at the inside function, which is f of x, which equals square root of x. And that actually has a domain of 0 to infinity, including 0. And that's because domain busters, you can't have the square root of a negative number. So the domain would actually be 0 to infinity. And now, using this, we can find the range, because we know that the domain is 0 to infinity, and we know that 1 minus x would actually have a range of all real numbers, because it would look like this. However, it has a restricted domain where where x has to be greater than or equal to 0, so it would be more like this. So the range is, and this goes on forever, so the range is negative infinity to 1, including 1. Similarly, we have to find f of g of x. So we first take f of x, which is just a square root, basically. So let's just do a large square root. And then we put g of x into that square root, because that is where the x was. So 1 minus x squared. And this is all square rooted. So now from this is our final equation, because this equals f of g of x. And now from this, we can compute the domain and range of this function. So first we have to look at the inside values, which is g of x. And we can see this actually has all real numbers because there's no domain busters. So this is irrelevant. So now we just look at this, the whole composite function. because f of x is on the outside, so we don't have to worry about that domain. So now we see that, oh, you can't have numbers less than 0 in this equation, because you can't have this term be less than 0, because then it would be a square root of a negative number, which we know isn't allowed. So we would do 1 minus x squared equals 0. We would set it to 0, and then we'd find the values that x equals 0. So we could minus 1 on both sides. So you have negative x squared equals negative 1, then divide by negative 1. So you have x squared equals 1, and then you square root. So x equals plus or minus 1. So now we know that this is when x equals, when this equation equals 0. So from this, we can find that we know the parabola faces down, right? Because there's a negative here. And we know that it has to intersect the x-axis somewhere. So from here, we can see that means the further left you go from negative 1 means you go lower and you get negative numbers, and the further right you go from 1, you get negative numbers as well. So the domain of this function, the domain of f of g of x would be, so domain would be negative 1 to 1, including, because this is a square root, so we can have 0. And from this we can find the range, where we can see this would be the range. So we can find the vertex, which in this case would just be 1, because you're going up 1. So this is a translation up 1. So the range would be 0, because we can't have a value less than 0, to 1, including. So here we have a much more complicated example, where we have f of x equals 1 plus x over x, and g of x equals 1 over x squared minus 4. And straight away here, you can see that both of these functions have a division sign, and therefore a domain buster. And this means that no matter what orientation we do, like f of g of x and g of f of x, we would always have a domain buster from the input value. So this is good to know, that like we don't miss it when we're going through the problem. So first off, we're trying to find f of g of x. So once again, we can write out f of x, 1 plus, and then right here we can do a blank over, again, a blank. And we can then write in g of x into those blanks. So we have 1 over x squared minus 4, and we have 1 over x squared minus 4. And here we can see that we can actually multiply the numerator and denominator by x minus 4. So you multiply the whole thing by x minus 4, x squared minus 4 over x squared minus 4. And this is basically the same thing as multiplying over 1, so we're not really changing the equation at all. So we get x squared minus 4 times 1 plus 1 over x squared minus 4 over 1, which equals x squared minus 4, because this is 1, because x squared over minus 4 over x squared minus 4 is 1. X squared minus 4 plus 1, which just equals x squared minus 3. So that would be our final expression, where f of g of x would equal x squared minus 3. Now from this, we can find the domain and range of the function. So we can find domain of this function. And for this, we can see that f of x, we need to find the domain of f of x, g of x first, sorry, and that is 1 over x squared minus 4. So we know x squared minus 4, we set that to 0, so we can exclude these values, and this is easy to factor. This is x plus 2 and x minus 2 equals 0, so x equals plus or minus 2. And we can see that this means that the domain, that this has to be excluded from the domain. And now in this function, this doesn't actually have any domain busters, which is good to know. So the final domain would just be the domain of g of x. So the domain of f of g of x is negative infinity to negative 2, excluding negative 2, u, negative 2 comma 2, u, 2 comma infinity, which is basically just a way of writing everything except for that. We can just say all real numbers except for x does not equal plus or minus 2. Now moving on to range, we can see that x squared has to be greater than or equal to 0. So, which means x squared minus 3 has to be greater than or equal to negative 3. And so the range is negative 3 comma infinity. But you exclude the values where x is plus or minus 2. And this is negative 3 because we can see this is a transformation down 3 and it opens up. So it would be here, so here, here, where negative 3 is the lowest value, so it's negative 3 to infinity. Sorry, down 3. Yeah, I think I said up 3. And we have to exclude the values of x equals plus or minus 2. So we have to find f of g of 2, right? So at x equals 2, x squared minus 3 equals 1, because 2 squared equals 4, so 4 minus 3 equals 1. And this would be the same for negative 2 because there's a square, and a square gets rid of the negative. So the final range of f of g of x would be including negative 3, comma infinity. Oh, sorry, this is an inclusion sign. Comma infinity, where we don't include where y does not equal 1. Now going back to the same example where f of x equals 1 plus x over x and g of x equals 1 over x squared minus 4. Now we're finding g of f of x. So we can start by writing out g of x. So that is 1 over, and then leave a space here for f of x. And I'm leaving a large space because it's a fraction. Minus 4. This is all under the radical. And here we would put 1 plus x over x. And that would be our composite, that would be our function. So now we would simplify. So we would get 1 over 1 plus x squared over x squared minus 4, because we can distribute we can put the square on both sides. And now we factor out, so you have 1 over 1 plus 2x plus x squared over x plus 4. And now we can make this into an over x squared, so we can go, we multiply 4x times x squared over x squared, so we get 1, which equals 1 over 1 plus 2x plus x squared over x squared plus, sorry, wait, this is a minus, sorry. This is a minus 4 4x squared over x squared. And here we go 1 over negative 3x squared plus 2x plus 1 all over x squared. Now don't get scared that there's two divisions. We know that division is actually just multiplying over the reciprocal, so we can do this equals 1 over negative 3x squared plus 2x plus 1 times x squared over 1, which just equals x squared over negative 3x squared plus 2x plus 1. And this would be our final expression for g of f of x. Now, from here, we would find the domain. So that would be domain. And knowing that f of x equals 1 plus x over x, we can say it is undefined. We can see there's a domain buster here, and that's just x equals 0. So x cannot equal 0 in the final domain. And we can also see that a g of f of x is undefined when the denominator here equals 0. So we set this function equal to 0. So you do negative 3x squared plus 2x plus 1 equals to 0. And we solve this. You had x equals negative 2. This is because 2 is b, 3 is a, and 1 is c. So negative 2 plus or minus the square root of 2 squared minus 4 times negative 3 times 1 all over 2 times negative 3. So you get negative 2 plus or minus 2 squared is 4, and this is negative 4 times negative 3 is 12, all over negative 6, which just equals negative 2 plus or minus square root of 16 over negative 6, which equals negative 2 plus or minus 4 over negative 6, which just equals x equals 2 over negative 6, which equals negative 1/3, and x equals negative 6 over negative 6, which equals 1. So we exclude x cannot equal 0, 1, and negative 1/3. So the final domain would be negative infinity to negative 1/3 union negative 1/3 to 0 union 0 to 1 union, sorry, this continues down here, 1 to infinity. Or you can just write all real numbers where x does not equal 0, 1, and negative 1/3. Now, from here, we can find the range of g of f of x. So this is a lot trickier, and if it is probably past the scope of your class, so if you don't want to get confused, don't watch this, but y equals x squared over 1 plus 2x minus 3x squared. So this is a rational function, and we'll find the range by noticing asymptotes. So at x equals 1 and negative 1/3, so as x approaches plus or minus negative infinity, y approaches, you basically just look at the largest thing, so you do 1x squared over negative 3x squared, you look at the coefficients, so that's just 1 over negative 3, so there is a horizontal asymptote at y equals negative 1/3, and it is also undefined at 3 points. the 3 points we listed here, but it's otherwise continuous. So this is range is all real numbers except for y equals except for possibly y equals -1/3, but we have to check that. So set x squared over 1 plus 2x minus 3x squared to equal to -1/3, and we get 3x squared equals -1 minus 2x plus 3x squared. So that's just 0 equals -1 minus 2x, so x equals -1/2. So that means there is an x value there, so we do include it, and the range is just -infinity to infinity, or all real numbers. So that was a pretty tricky one, but if you work it out through just normal algebra, you'll find it.